Alright, hey guys, this is your review day for 5.1, 5.2. You should have already tried this warm-up, should have taken you roughly 5 minutes or so, and now I'm going to go over it, okay? So you're given a system of equations, and we are going to solve it via substitution, the way we learned last class. And here are the steps broken down for you in case you forgot. So first step is to get one variable alone. So you need to get either the x or y alone in one of these two equations. And sometimes this is done for you. Like we were lucky in this case because y is already alone, okay? So we know that y equals 3x. Then we're going to substitute the isolated variable in the other equation. What that means is we're going to take what y equals here, which is 3x, and replace this y in the other equation with that value. So y is now going to be 3x. So 7x minus 3 times 3x equals 8. Okay, we are happy when this new equation should only have one variable, like one variable type. So this only has x. We're happy, okay? If it has x and y, you can't solve it, right? You can't solve for one variable alone for a number, okay? So we're going to simplify and solve this new equation, so let's go ahead and do that. So we're going to distribute this negative 3 into this 3x. We're going to get 7x minus 9x equals 8. 7 minus 9 is negative 2x equals 8. We're then going to divide by negative 2, divide by negative 2, so x will equal negative 4. Okay, so we know one of our values, but remember, we're looking for a coordinate, right? We're looking for an x and a y. We got the x, we got to get the y. So we're going to substitute the value we found into one of the old equations and solve. So it doesn't matter which one of these two I choose. I'm going to take this value, x equals negative 4, and plug it into one of them. So let's do the easier one, which is y equals 3x. I'm going to take y equals 3x, and I'm going to replace x with negative 4. Okay, so it's going to be y equals 3 times negative 4. That is y equals negative 12. Your answer should always be a coordinate, so it will be negative 4 comma negative 12. Okay? All right, good job. So if you got that, well done. If you didn't quite get that, make sure you go over that homework a little bit more, maybe do a few more practice problems, make sure you're familiar, follow these steps. And we're going to get going with some reviews. So you're going to have a quiz next class. So on day 2 this week, day 1 next week, you're going to have a quiz on these first 2 sections. So you need to know like sort of how to solve systems of linear equations, both graphically and through substitution, and like understand whether a point is or is not a solution. So at this point, guys, you want to pause the video, stop the video, and do this practice quiz. Like do it to the best you can. You can like use your notes, like ask each other for help if you get stuck. But do everything you can. Do not just watch me do it and copy it down. You want to try it yourself. When you've got it down, when you've done as much as you can, then come back, play the video, and watch me solve it. Okay. All right, I'm going to get started. First question. Tell whether negative 1 comma negative 5 is a solution to the system of linear equations. So if it's a solution, that means that it should work for both of these equations. So for y equals 3x minus 2, when I plug these values in, it should be true. So remember, this is my x and this is my y. So it's going to be 5 equals 3, negative 5 equals 3 times negative 1 minus 2. That's negative 5 equals, that's negative 3 minus 2, that is negative 5. So it's good. So that is a point on this first equation. So far so good. Let's check the other one. Negative 2x plus y equals 3. So that's negative 2 times negative 1 plus negative 5 equals 3. That is, so negative 2 times negative 1 is 2. So 2 minus 5 equals 3. So that's negative 3 equals 3. Is that a true statement? Does negative 3 equal 3? No. No. So this is not equal, so this did not work. So that means -1, -5 is not a solution because it is not true for both equations. Okay. So, or your own version of that, but I need you to tell me that that coordinate does not work for both of these equations, and that is why it is not a coordinate. Okay? All right. Number 2. Here, let me zoom in a little bit, make it a little easier. Given the system of linear equations, answer the following. Draw and sketch the 2 lines in the graph provided, then use the graph to solve the system of linear equations. So, let's write them out one at a time, guys. You're in the test, or you're in the quiz, you're going to take your time, right? We're going to do things slowly. I'm going to write it out, and I'm going to label what is the y-intercept. Well, the y-intercept here is 2, so it's just 0, 2. My slope is 1. So I'm going to go ahead and plot this. So 0, 2, and then a slope of 1. So right 1, up 1, right 1, up 1, and so on. And then I'm going to take my straight edge, and I'm just going to connect those dots, okay? All right, so that's my first one. Then I've got y equals -6x plus 9. So these are nice, right? Because they were written in y equals mx plus b form, right? These were kind of, you know, these were nice, kind of easier problems because they're already written in y equals mx plus b, right? So you can already tell me the y-intercept and the slope. So be ready, you might see a kind of problem like from your homework where you're not given it as just straight y equals. It might be mixed up, right? And we'd have to move it, okay? So in this case though, my y-intercept is 0, 9. My slope is -6. So we'll go to 0, 9, and we'll go right 1 and then down 1, 2, 3, 4, 5, 6, down right 1, 1. 1, 2, 3, 4, 5, 6. Okay, and I can hit my straight edge. Connect these 3 points here. And there we go. Let's put some arrows on the end. Okay, so I've graphed it well. And I can see that I have a point of intersection here at 1, 3. So 1, 3 is the point of intersection. So that's the solution. Okay? Good? Okay. All right, based on this, on the following graph of a system of 2 linear equations, what can you say about the solution of the system? So we're looking at this, the lines are parallel. So the lines are parallel. What does that mean? So remember, that the solutions happen when they intersect. So if they're parallel, they will never intersect. The lines are parallel, so they will not intersect, and there is no solution. Okay, so if 2 lines have the same slope, there will be no solution. Okay, all right. So we got a substitution question next. Okay. So looking at this, the variable is not alone, right? The variable is not alone, and that's our first step. If you remember from the warm-up, we need to get one of these variables alone. So like looking at it, I mean, definitely the second equation here is going to be easiest to get a variable alone. Let me write it out. And I can choose either x or y. It doesn't matter. You can choose either one. I'm going to go ahead and make it my x. So I'm going to say that x equals -3 minus y, right? I'm going to subtract y from both sides here. So now I have x alone. Then I'm going to take my x and plug it in for the x value in my original equation, my first equation here anyway. So it would be 5. And then instead of x, -3 minus y plus 2y equals 9. Right, I'm happy because I've got an equation that's all written with one variable, and now I can solve it. So it's going to be -15 minus 5y plus 2y equals 9. Let's combine like terms here. This is going to be negative 15 minus 3y equals 9. I'm going to add 15 to both sides, and we're going to get 24 equals negative 3y. We're going to divide by negative 3, divide by negative 3, y equals negative 8. Okay, so y equals negative 8. I'm going to then take this value and plug it into one of these two equations above. It doesn't matter which one. I'm going to do the second one. So I'm going to say x plus negative 8 equals negative 3. Okay, well that's just x minus 8 equals negative 3. Then I'm going to add 8 to both sides. So then x must be 5. So combining these two, my coordinate would be 5, comma, negative 8. Okay, so one more time. First, variable alone. Plug in that variable to the other equation. Solve for one of the variables. Take that value, plug it into either of the original equations, get your second variable, done. Okay, last question. A theater earns $36.40 from a concert. An orchestra ticket costs 3 times as much as a balcony ticket. There were 148 orchestra tickets and 76 balcony tickets sold. What is the price of each type of ticket? Write a system of linear equations that represents the situation and solve a system using substitution. Show all work. Okay, so we earn this much. Okay, let's just like kind of underline the things we got. We know that an orchestra ticket costs 3 times as much as a balcony ticket. Okay, we know that there were 148 orchestra tickets, and we know that there were 76 balcony tickets. So we need to figure out the price from this information. Okay, so let's start with the price. We know we made $3,640 from the concert, so we're going to take $36.40, and that's going to equal the price of a balcony ticket. We'll call that B. So over here, let me say B is going to be balcony, and orchestra is an O, but like O looks like a 0, so I don't want to use O. Let me use like an R. R is going to be orchestra. Okay, so we're going to have $36.40 equals the price of a balcony ticket plus the price of an orchestra ticket. But we know that the orchestra ticket costs 3 times as much as a balcony ticket. Okay. We also know that there were 148 orchestra tickets sold and 76 balcony tickets sold. So what we're going to do is we're going to set B and R to be the price of these orchestra tickets. Okay? The price of these orchestra tickets. So we're going to say we know that $36.40 is going to be 76 times the balcony ticket price, and then 148 times the orchestra ticket price. And I know down here that the orchestra ticket, the R, is 3 times as much as the balcony ticket, so R equals 3B. Okay? Do you all see how this worked? So we earned $36.40 from a concert. So I'm like, okay, I'm gonna use that $36.40, and I'm definitely gonna have to use like something about the balcony tickets and the orchestra tickets. But it told me how many orchestra tickets and balcony tickets there were, so that wasn't gonna be my unknown. The unknown had to be the price. And so by setting the B and the R as the price of the balcony or orchestra tickets, and knowing that the orchestra tickets were 3 times as much as the balcony tickets, now we can solve. So we can say that $36.40 equals 76B plus 148, then that's 3B. Okay? So let's keep going here. $36.40 equals 76B plus 3 times 148. Let's see here. 3 times 148 is 444. 444b. Then we're going to combine these, so it's 3640 equals 76 plus 444 is 520. And so 3640 divided by 520, that's 7. So B, basically a balcony ticket costs, balcony ticket price was $7. Okay. Therefore, using the R equation up here, the orchestra ticket price would be 3 times 7, which is 21. That means that the orchestra price is $21. Okay. All right, that is the practice quiz. So to keep practicing, I recommend doing the optional delta, and you will be ready for your quiz tomorrow. Good luck, guys.